Hey guys, it's Assistant Principal Udo here again, and today's math lesson for Wednesday, January 6th is on the associative property. So let's get ready to get started. Please make sure at this time that you have your math journal and a pencil ready. If you do not have your math journal and a pencil, please make sure that you have a piece of scratch paper that you can put in a folder or a notebook or in a safe place for you to refer back to later. Also, make sure that you have your Google Classroom tab open, as your assignment for after today's lesson will be in Google Classroom. You also want to make sure that you come with an open mind and a positive attitude so that you are ready to learn. On the screen right now, you will see our math norms. Our math norms are the same every day, and they are just quick reminders to let us know of why we are here and what we will get out of it. The first is that errors are gifts that promote discussion. The second, ask questions until ideas make sense. Number 3, talk about each other's thinking. Number 4, answers are always important, but they are not the math. And number 5, use multiple strategies and multiple representations, which we spent an entire day doing yesterday. I also want to quickly remind you that whenever you see a pencil on the screen, that means that you should be writing down whatever I'm writing down. Let's begin today with our warm-up. Remember, for your warm-up questions, sometimes you may want to write the work down so that you can solve it on your paper. And other times, the questions may be those that you can solve mentally. Either way is fine. Just always remember that when prompted, that you answer the question on your Nearpod. Question 1. Miss Bennett's classroom has 6 rows of desks with 6 desks in each row. She wants to figure out how many total desks she has. Which array and equation can she use to help her find out how many desks she has? I'm going to read it again. Miss Bennett's classroom has 6 rows of desks with 6 desks in each row. She wants to figure out how many total desks she has. Which array and equation can she use to help her find how many desks she has? The question is going to pop in the Nearpod in just a second, but I want you to take a moment and make sure that you look at the answer choices before it does. All right, let's check our solutions. If you remember from Monday's lesson, when we talked about the distributive property, we talked about taking problems and breaking them into smaller pieces to help us solve. Let's see if we can eliminate some choices. Well, first and foremost, we have been talking about multiplication. So we know that B is not the correct answer. It looks simple. It is just not what we're looking for. And if Miss Bennett has 6 rows and 6 desks, she doesn't just have 12 desks. There's a lot of desks in the middle. So we know that that is not the correct answer. Now, taking a look at answer choice C, while answer choice C now has some multiplication involved, if you look very closely, it's the exact same problem. Answer choice C uses what we call the identity property of 1. The identity property of 1 tells us that any number that we multiply by 1 is itself. So 1 times 6 is 6, and 1 times 6 is 6. And when we add them together, we still get 12. And we know that Miss Bennett has way more desks in her class than that. Otherwise, there wouldn't be enough places for everybody to sit. So we're going to mark that choice out. Now, let's look at A and D, because one of these is going to get us to the total number of desks that Miss Bennett has in her classroom. When I look at answer choice A, I see that she has 3 rows and 6 columns plus 3 rows and 6 columns. When I look at answer choice D, I see that Miss Bennett has 2 rows and 6 columns and then 3 rows and 6 columns. And I know from my problem that she has 6 rows, and if there's 6 desks in each row, that's my 6 columns. So we are looking for 6 rows and 6 columns. So what I'm going to do is I am going to add and figure out which would give me the same number of rows and columns that Miss Bennett has. Well, if I count my rows in A has 1, 2, 3 rows, 4, 5, 6. Let me use a regular pencil, guys. That's a little messy. Let's do that again. All right. So 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows. Okay, so that meets the first part of my question. Well, let's look at D. D, if I add my rows together, I've got 1, 2, 3, 4, 5 total rows. So that tells me that the correct answer for this problem is A. How'd you do, guys? Let's get into our math. One more. Sorry. Question number 2. Kanisha says that when you count by sevens, some of the numbers are even and some of the numbers are odd. Do you agree or disagree? And you're going to answer in a complete sentence using the sentence frames below. I agree with Kanisha because, or I disagree with Kanisha because. Reading the question one more time. Kanisha says that when you count by sevens, some of the numbers are odd and some are even. Do you agree or disagree? Use a complete sentence and look at the multiplication table to help you. You should be answering in the Nearpod. Let's check our solutions. So just like we had another problem like this before with Dylan, and we looked at the sevens times tables in our multiplication table. And remember, I shared with you the last time we did this that when we're determining whether a number is even or odd, we're looking at the digits in the ones place. And so we have a 7, a 4, a 1, an 8, a 5, a 2, a 9, a 6, a 3, and a 0. All right, let's see. We talked about what digits or what numbers were even and what numbers were odd on yesterday. As a reminder, 2, 4, 6, 8, and 0 are even, and 1, 3, 5, 7, and 9 are odd. Well, when we take a look at the digits here, and I'm going to rewrite them on the bottom just so that we can see, and I'm not going to write the whole number. I'm going to write the last digit, the digit in the ones place so that we can look at them. 7, 4, 1, 8, 5, 2, 9, 6, 3, 0. Whew, these numbers are all over the place. Well, here's what I'm going to do. Let's go through and figure out which of these numbers are even and which ones are odd. I am going to highlight my even numbers in green. So I've got 4, 8, 2, 6, and 0 in green. And I'm going to highlight my odd numbers in yellow. So 7, 1, 5, 9, and 3. You guys want to know something that's super crazy? Now, while I am going to say that I agree with Kanisha, because Kanisha is correct, there are even and odd numbers here. Another thing that I noticed is that all of the even and odd numbers are here. We could take these numbers and put them in order, starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So not only are the numbers even and odd, so Kanisha is correct. I agree with her. But I also noticed that on the 7 times tables, every even and odd digit is represented. Whew, that's a lot to think about. Let's go ahead and jump in with today's lesson. Our objective for today is that I can explain and represent the associative property of multiplication, and I can also be precise in my work. Our key term for today is associative property. And associative property tells us that multiplication facts can be multiplied in any order, no matter how they are grouped. So let's take a look at our anchor chart today. It says 3 or more factors can be grouped in different ways before being multiplied without changing the product. And so what that means is, taking a look at this first one, they multiplied 2 times 3 times 5, and they got 30. And then they switched it up. They did 2 times 3 times 5 is 30. They moved the parentheses. The number stayed in the same place, but they moved the parentheses, meaning that what they did first changed, and the answer was still 30. Over here, 3 times 5 times 2 is 30. We move the parentheses. This time we multiply the 5 and 2 together first and got 30. Over here, 5 times 2 times 3 is still 30. If I multiply the 2 and the 3 together first, I still get 30. So this is the idea that we're going to explore today, guys, that no matter what order you multiply in, the answer will remain the same. The product will not change. Let's look at our anchor problem for today. Juan worked for 2 hours a day and was paid $5 an hour. If he worked for 4 days, how much money did he make? Well, let's go ahead and start talking on our Nearpod about what this problem is about. My first question for you is, how many hours did Juan work? Write your answer on the Nearpod. How many hours did Juan work? Did you say that Juan worked for 2 hours? If you did, you're absolutely correct. Juan worked for 2 hours. Next question for the Nearpod. How much money did Juan make for each hour of work? How much money did Juan make for each hour of work? Write your answer in the Nearpod. Did you say that Juan made $5 an hour? Juan made $5 an hour. So for each hour that Juan worked, he made $5. Last question for the Nearpod. How many days did Juan work? How many days did Juan work? Write your answer in the Nearpod. Did you say that Juan worked for 4 days? That is correct. Juan worked for 4 days. All right. Well, it looks like you're ready to solve the problem. Let's get your pencils ready. We are going to model this problem together. And I am actually going to make an array to model this problem. And so, as a reminder, Juan worked for 2 hours a day and was paid $5 an hour. If he worked for 4 days, how much money did he make? So let's start by thinking about how much money Juan would make in 1 day. So for each hour of work, how much did Juan make? For every hour, he made $5. So I am going to model Juan making $5. And I'm going to use dollar signs this time for my array. So there is $1, $2, $3, $4, $5. And so this is going to represent how much Juan made in 1 hour. In 1 hour, Juan made $5. Well, in our question, we said that he didn't just work for 1 hour, he worked for 2 hours. So the first picture showed me how much he made in 1 hour. If he worked for 2 hours, Juan would make another $5. And so if Juan worked 2 hours, as the problem told us, he would make an extra $5. And so in your Nearpod, tell me, how much was Juan paid for 1 day of work? Here's our question right here. How much money did Juan make for working 1 day? If he got paid $5 an hour and he worked 2 hours a day, how much money did he make in 1 day? Answer in the Nearpod, please. Well, let's see if we can figure it out. Each of my dollar signs represents $1, and there are 1, 2, 3, 4, 5. That's his first hour of work. 6, 7, 8, 9, 10. That's his second hour of work. So Juan made $10 in 1 day. Did you guys get that? All right, guys. Well, guess what? We're not done yet. Keep those pencils rolling. It says that Juan worked for 2 hours a day, was paid $5 an hour, but he worked for 4 days. So how much money did he make? Well, in our last problem, we learned that Juan, let me spell his name right. We learned that Juan made $10 in 1 day. And we want to know how much he made in 4 days. Yesterday, we learned a lot of different strategies, and you could use any of those strategies to answer this question right now. We are trying to figure out how much Juan made in 4 days if we know that he made $10 in 1 day. Take a second and think about one of those strategies that you learned yesterday. And I want you to try to use that strategy to tell us how much Juan made from working and answer on the Nearpod. So what strategy did you guys decide to use? Did anyone use a tape diagram? $10 for Juan's first day, $10 for his second day, $10 for his third day, $10 for his fourth day. Did anybody make a number line? All right, starting at 0 and then $10 for day 1, $10 for day 2, $10 for day 3, $10 for day 4. Did anyone make an array, or could you possibly use an equation? There's so many different things that you could have done, but did you find out that Juan made $40 from working? If you did, you are absolutely on the right track. And so let's talk about what that looks like when we are actually looking at an array or an equation. The associative property says that you can group numbers in any order, and so we're testing that out now. So this picture represents each day that Juan worked. We have day 1, day 2, day 3, and day 4. This is each day that Juan worked. Remember that first row was his first $5, and then the second row is his second $5. And he worked for 4 days. So 5 times 2 is 10, and 10 times 4 is 40. So remember, guys, I told you that the associative property means that you can multiply in any order. And so we multiplied 2 times 5 is 10, and then we multiplied it by 4 to get 40, but you could also switch it up. We could also multiply 5 times 4 and then multiply it by 2. Let's use an array to do that at this time. If I want to count my rows here, I have 1, 2, 3, 4, 5 rows and 4 columns. And my other picture is exactly the same. It is also 5 rows and 4 columns. Well, I can skip count by 5s to solve this. 5, 10, 15, 20. So that tells me that there are $20 in this array. And this one's exactly the same. It's got $20 in it as well. Now, I could use a distributive property and just add these two up and know that 20 plus 20 is 40. In this case, however, they want me to multiply by 2. So they are multiplying 20 times 2. Because this is a big problem and we haven't talked about it yet, this is one where we would use the distributive property. Instead of multiplying 20 times 2, I would think about something that I knew that was smaller, which is exactly why we multiplied 5 times 4 and 5 times 4 and added them together in order to get our 40. Whew, that's a lot of work, guys. But guess what? Now it is your turn. Now it is your turn. This says, if Juan worked 4 hours a day for 2 days and still made $5 an hour, would he make the same amount of money? So our problem has changed just a little bit. Let me remind you, in our first problem, Juan worked 2 hours a day for 2 hours a day, was paid $5 an hour, and he did this over 4 days. In our problem now, Juan works for 4 hours a day for 2 days, and he makes $5 an hour. And the question is, would he make the same amount of money? I don't want you to answer that question in the Nearpod just yet, though. I want to know what multiplication equation you would use to represent this problem. In the Nearpod, what multiplication equation would you use to represent this problem? hope that you said something along the lines of 4 times 2 times 5 equals something. Or maybe you said 2 times 5 times 4 equals something. Or you might have said 5 times 2 times 4 equals something. No matter what order you put your factors in, you would be correct, because remember, that is what the associative property does. Next question. Which set of arrays models the expression above? Which set of arrays models the expression above? Take a long look at the picture, and then the question is going to pop up in your Nearpod. All right, so for this particular question, let's look literally at our expression. Our expression has a parentheses around 4 and 2. So 4 times 2. Let's see, I've got in A, 1, 2, 3, 4, 4 rows and 2 columns all the way across, which would be a nice model for 4 times 2. And then my last factor was times 5. And this array appears 1, 2, 3, 4, 5 times. So your correct answer would be A. Let's look at the next one. Think back to that very first question I asked you. Which expression below would give you the same answer? Take a long look and then provide your answer in the Nearpod. Which expression below would give you the same answer? So remember, the associative property tells us that we can move the numbers around, not that we can change them. So we know that the answer is not A because there's no 3 in our original problem. We know the answer is not B because there's no 6 in our original problem. We also know the answer is not D because there's no 1 in our original problem. Answer choice C has a 2, a 5, and a 4, just like our original problem. So the correct answer is C. All right, guys, you did an amazing job today. Let's review. The associative property tells us that 3 or more factors can be grouped in different ways before being multiplied without changing the product, meaning that we can move our numbers around, we can multiply in any order, and our answer will still remain the same. For the remainder of class, there is an associative property lesson posted in your Google Classroom. It is 5 questions, and the questions can be read to you if you choose. You may have to log into Clever in order to access it, so make sure you do that. If you finish those questions before class is over, please log into Dreambox for the remainder of class. Great job today, guys. I will see you tomorrow.